So we've kind of avoided the calculator so far when doing derivatives, and there's been a reason for it. It's not just so that you can get used to how do we find derivatives and what is a derivative without growing dependent on the calculator. It's actually, the calculator can't actually evaluate derivatives exactly. Calculators can only estimate them. Now, I will admit, the estimates are really, really good estimates, but the calculator does make mistakes. So there's going to be time in which the calculator will tell you, hey, I think the derivative is this, and you're going to need to be knowledgeable enough about derivatives to be able to say, ooh, no, that's not the right answer. The calculator's telling me something incorrect. Because, surprise, you're at the point where the math is advanced enough, a calculator's not always going to give you the right answer, even if you type everything perfectly. Um, and the reason for this is uh, our calculators don't actually do limits. So our calculators, they can find the slope between 2 points, but they're not able to move them infinitely close because calculators have to be able to deal with real numbers. And infinity is not a real number. And so it can't deal with 2 points that are infinitesimally close together. What it does is instead of using the difference quotient, it uses what's called the symmetric difference quotient, which is still finding the slope between 2 points, but it can't move them. Instead, it makes them a fixed distance. 1 point is 0.001 units to the right of the point of tangency. The other is 0.001 units to the left of the point of tangency. And it says, let's find the slope between those 2 points. And this is actually where the problem comes in. It ignores the point of tangency. So we have to be careful with this. Where calculators tend to make mistakes is at the 4 places on a graph, a function is not differentiable. So at corners, at cusps, at vertical tangents, at discontinuities, the calculator doesn't always notice that they're there. Now the TI Nspire, if you're using that, the software updates have gotten better and better with those in terms of they've just updated the memory system to be like, hey, if there's a discontinuity, give a warning that the derivative may not exist. Or, hey, we think that there's a corner here. They're not always right, though. So you have to know more than the calculator for this. You have to know if there's a corner, a cusp, a vertical tangent, or a discontinuity, that the derivative shouldn't exist there. So an example of what causes what's happening and why it doesn't always fix itself is I'm going to go to my absolute value of x function because this is one I can work with easily, mainly because I already know that the slope coming from the right at x equals 0 is 1, and the slope coming from the left of x equals 0 is -1. So I already know that f prime of 0 does not exist because the left and right-hand derivatives aren't the same. But if I use the symmetric difference quotient, what we're saying is let's move 0.001 units to the right. So my x is going to be 0.001. And then my y is the absolute value of that. And then it says, instead of using my point of tangency, let's also move 0.001 units to the left. So my x coordinate's negative 0.001, the y coordinate's the absolute value of that. And now it says, let's find the slope between those 2 points. And when I do that, it says, well, f prime of 0 is going to be about 0.001 minus 0.001 over 0.001 minus negative 0.001, which gives me 0. So I'm being told the derivative is about 0, but because of the corner, I need to know the derivative doesn't actually exist there. Now, if you type this on your calculator is going to give you a warning that says, hey, we're pretty sure the derivative doesn't exist there because our calculators received updates to try to catch that, but it doesn't always catch them. So you need to know whether or not the derivative should exist before you type it in the calculator.